Hello and good morning. My name is Klaus Degner. This is the Allegro 3.0 webcast, and today I would like to inform you about which new features and improvements have been developed for the Allegro. And well, of course, the immediate question is, why did we call it 3.0? So what's the major step behind it? The major step is quite simple to explain. We started with the Allegro 200 almost 5 years ago now, and this Allegro 200 was the base operating system we used for all Allegros. So time passed on, there are new chipsets available, there are new CPU extensions available, and to get the best use out of it, we needed a new operating system with new kernels, everything new. The problem here is always you can either discontinue all products and go to a new system. We decided against. We decided, okay, even the Allegro 200 is a platform we would like to support in the next years. So we decided, okay, we upgrade all systems to a new base platform. You can compare it like a complete Windows upgrade or a Linux upgrade from an old distribution to a new one. This upgrade has the big advantage that we can continue supporting all Allegros from the very small 200 up to the 5500 with the same firmware. Plus, we can support all the Allegros. So there is no end of sales, end of support for any of our platforms. We solved it by having the new base system. The new base system, of course, requires a complete restart of the appliance. And the downgrade is not as easy as it was before. So today, if you would like to downgrade to 2.6, you have to do it via the boot menu. Okay, this was a very big step for us to really get all new libraries, which allows us to add a lot new features to the Allegro. Now I would go a little bit more into detail, and I would like to show you, let me just put that on full screen for you. Let me go through a few of the new extensions that we have developed and which are very helpful to use for the Allegro. Number one is one of the most requested features. It looks easy, but it's quite complicated. It's that we have splitted the menu. So the top menu and left menu are now static, and you can scroll up and down, and the menus are still there. In addition, you can remove the menu on the left side, which uses, gets you the full screen for the data. We also added an easy way to see which filters are active. The problem what we have seen in troubleshooting cases where we did the support, that there have been filter applied and we couldn't get captures from the ring buffer. And now it's a very easy way to see, okay, do I have some filters or what filters are active? So for example, here on this box, we have an ingress filter on the MAC addresses. So 2 MAC addresses are not recorded. And we have 3 MAC address filters on the ring buffer. So where we don't record things on the ring buffer. Okay, this looks easy, but it's quite complicated to add. The next thing, which was also a big customer request, is that the download should be improved. Up to now, the only way to get a PCAP was doing a capture to disk and split this capture. Then you have a lot of PCAPs on the disk. You have to download one by one. The other way was get a very large capture and store that on your disk and then use some command line tools to split this. So if you, for example, would like to download here an extreme big capture from a server, let's take these 487 megabytes, but you're interested in doing a download on it as a zip archive, you can now activate here this feature that the browser download should be zipped, which is done in real time. Plus, you can split this file. So if I would take here 10 megabytes and start this download, I get now a zip archive, and this zip archive now includes 10 megabyte capture files each. That allows you to store captures and analyze them a lot more easily back in time, and that makes it a lot easier to process. We also added, let me stop that capture here. We also added an easy way where you can just rename the file name, because maybe you know this is my capture, and now you can start, if you start now this capture, then the file name is already set to the browser and you don't get our cryptic naming. Of course, you can include the template here for specific things you would like to add automatically, but this helps a lot that you can do easier PCAPs. Okay, next feature is the deduplication. Let me go back to my list. So the packet deduplication. We got a lot of requests if we can do a packet deduplication. There are good and bad things about packet deduplication. Well, we have located that as the ingress filter because the deduplication will remove packets before we process them. As we do things in software, we are a lot more flexible compared to any ASIC switch-based deduplication engine. And we started now with what we call a minimum viable product. So the packet deduplication is easy to use and easy to work. If you have requests for extensions, if you have requests for, or if you have a specific setup where you need more features, please let us know. By the way, the best way to inform us about new features is, of course, your partner, is, of course, our sales. But there's another way which is also very helpful. You can go via our support. So support@allegro-packets.com. I also get these tickets from the support system and handle there all the feature requests and be informed about what's happening there. Coming back to the deduplication engine. If you activate that, there's of course a hash table where we store all checksums of the packets to detect duplicates. You can configure the timeout in milliseconds from very little to, well, 1 second. If this is not enough, we can even increase this. You can say, where should we compare? Should we start at layer 2 or layer 3? The reason is, if you need deduplication and you have a routing between, then of course layer 2 will change, but not layer 3. You can start at layer 3. And then you can select how many bytes shall we include for the checksum. 128 is usually enough. If you need more, you can just fill in here 9K, for example. Please note that the more you use, of course, the more time consuming it is. It is quite fast. So having here a higher value is, you will see it in the performance stats, but very little effect. Then of course you can ignore specific fields if they are changed, but it's still a duplicate. What we also added, and that was very good for us for troubleshooting, for debugging, is a capture button for duplicate packets. This is a special code path for us because usually duplicate packets are discarded. and ignored. So they are not in the ring buffer. They are not in the processing. So you don't see them in any statistics because they're discarded. So we developed a way that you can store in real time or get the PCAP download of it of deduplicated packets. So of the discarded packets. This helps you easily to see if the deduplication is working. Giving you a good example, what we realized when we tested it. The deduplication is working very well, except for two kinds of packets. Number one is TCP resets. A reset, usually in IPv4, has the IP ID 0. So if you have multiple resets within this timeout, within this packet timeout, you see a duplicate packet. It's exactly the same packet. Even worse, it's for IPv6. IPv6 has no IP ID anymore. So a retransmission, which retransmits exactly the same bytes of a packet which has been lost after the Allegro, so we see it twice, is exactly the same packet. The problem there is that there's no way to detect, oh, this is a real deduplication, or so it's a real double packet, or it's a retransmission in this case. What we also did is you can enable this deduplication engine, but by the virtual link groups, you can decide this virtual link group, should you do deduplication on that virtual link? The background is very simple. For example, you have bigger Allegro appliance with many ports, and you would like to monitor multiple links, and on one link you have duplicate packets. Then you can use a deduplication only on that link. And this allows, again, to use a multimeter for multiple links in one location and optimize the setting even per link. Okay, this is packet deduplication. The next feature on my list is the DNS module. We extended the DNS module because there was there were multiple customers requesting for more detailed statistics. The problem with DNS is that if you have DNS issues, the whole network is bad. If one client has issues and it's DNS at the end, you need to debug a lot more into detail. And so we decided to do more real-time statistics per DNS server. So for example, if you take our DNS server, I can look now into, well, of course, the request response time, what was the average response time, but also reply codes. Now I can look into what were the top DNS names, what was the request response rate, how many have been not answered. And now, of course, I can sort by unanswered requests only, but I can again sort by requests. And that makes it very easy to look into, okay, which requests have been answered, how much errors have been there. Also, what is very helpful is which requests have been not answered by the Allegro and what are the names. Here we see a lot of pages. Plus, what are the non-existing domains? So which URLs have been called on that DNS server and they don't exist. So this is, for example, an all test device in our office and it's turned off. So this Allegro MM895E and the other one also. But it looks like someone is pulling this box. Maybe it's our Zabbix server who is taking care of all our inventory. So we could look easily here and see, okay, no, in this case it was a developer who asked for this IP address and so the last request to this DNS name. Yeah. And so you can go into detail and see, okay, which non-existing names are still used. This is very helpful to find outdated servers, not updated inventories where machines are polling for names which do not exist anymore. And again, of course, you find that for every DNS server. So for example, if we see here Google DNS, then we can look into the Google DNS, what has been asked here, crazy name, and it looks like there are some Android devices looking for that, for these Google 8888 DNS server. This is we got first response on that on test customers, and they said it's really helpful because it reduces the debugging time for DNS very much. Next topic on my list is VoIP. In the last months, we have seen a dramatic increase in VoIP traffic in companies, especially on WAN links. We have seen a dramatic increase on RTP connections. So we decided for the release 3.0, we improve the SIP statistics. Let me go into detail here for a few cases. So with up to now, you only got a very, very big page where you see a lot of status, statistics for a specific call. What we added now is that you have a call detail page. The call detail page allows you to look into, all the information that's available for one call on one page. So here you get all the information in a better way to display. We also added an RTCP decoder, which is extremely helpful for debugging end-to-end problems. RTCP is the control protocol of RTP, and it's sent by the end devices. So many end devices support RTCP reports, and they are telling the other telephone about the quality. Number one, they are telling what is the packet rate they are receiving, plus how many packets have been lost. Very interesting, for example, here for that call is, we see that there is no loss reported, either by callee and by the caller. So you can be extremely sure that all packets have been received, or all sent packets have been received by the other side because there is no loss. And so this call was on RTP, 24,000 packets and 0 loss. So if someone blames the network for the bad VoIP quality, not on that SIP connection, I would say. Again, we have the jitter and we see the drop packet, of course, measured by the RTP packets. Here, again, you now get also the capture, not only of SIP and RTP, but also of the RTCP traffic. So if you would see that in WebShark as a preview, we could filter here for RTCP, typo, RTCP, and then we see all the RTCP packets, for example. We also added a few more values. So one is the expected and seen sample rate. We have seen VoIP installations where they used the codec with 8 kilohertz, but they sent only 5.3 kilohertz. And this caused a problem. All the statistics were good, but the sample rate was wrong. So that was the mismatch here. And we also added on the audio level, not only the min and max decibel value, we also added the RMS value, which is a root median distribution, which is at the end the change of the amplitude. So the loudness of a call is measured by the RMS value. And there are some, if you come from the VoIP world, that's a very important value because that tells you a lot if the call is too loud or if the loudness is not good enough. So we added that. Last but not least, for some providers, we added the feature to show correlated calls. This is very important if you measure before and behind an SBC. So you have a session border controller which terminates SIP connections and forwards them to other SIP providers, for example. In that case, if you have a call, you can see correlated calls, which have the same call ID, or there are some other metrics, of course, to do that. In that case, you can see on one page a call and all other calls, which share the same call ID. The big advantage here is, because you can switch here with the graph selector, I will explain later which graphs you would like to see. The big advantage is you can see on one page, oh, that was the call on one side or on one leg and the call quality on the other leg. We discovered with that feature, for example, an SBC system that dropped all RTP packets with a jitter more than 20 milliseconds. So we saw on one end jitters with up to 30, 40 milliseconds. On the other leg, we saw drop packets at the same time where the jitter was high, plus the jitter was then low on the other side. So then they know, okay, this SBC system actively drops all packets with a jitter higher X and could go back to the which was not documented, and they could go back to the vendor and say, okay, is it how can we configure that value? How can we change it? So that was an easiest thing they debugged with the Allegro in that case. Okay, let me go back to my long list. VXLAN and VN tagging, decapsulation support. We see more and more installation where we have VXLAN. VXLAN sounds very similar to VLAN, but it's completely different. On protocol level, VLAN is a few bits between layer 2 Ethernet and layer 3 IP, so usually 4 bytes only. VXLAN is a complete IP UDP, and then in that UDP tunnel, a complete Ethernet packet again. So you have after layer 4, again, a small header, layer 7, and then layer 2. So the decapsulation here is a lot more complicated. We decided to add this feature at generic settings to the tunnel view mode. Up to now, if we have ER-span packets, we can decapsulate them, for example, in a PCAP or so. We added to this tunnel view mode also VXLAN. So if you have a VXLAN installation, just turn on this mode. Don't forget to press Save Settings. And then the tunnel view mode, well, the Allegro will look into the tunnel. We implemented that. It's also in the release notes for 2 static ports, one from IANA, and of course Cisco uses a different port. It's Cisco. And so both tunnels have been tested on customer sites and they're working. In addition, there is a special output for some virtual networks for Cisco hardware, which is called a virtual network tagging. This is also a layer 2.5 protocol between layer 2 and layer 3, and it adds information for how which virtual network has been mirrored. And we added principally the support to detect this header and skip it. So if you do captures with that, now you can see the packets, which are VN tagged. Okay, we are half through roughly with my list. Next item is the improved ER-span support. And we added the ER-span support with release 2.6. And we got quite a lot of customer feedback that it's working, but it's hard to debug if something is not working. So if you activate this layer 3 tunnel mode here, which accepts ER-span, but also VMware generated tunnels, then you just activate that for a specific interface, you give it an IP address, and then you can configure on your Cisco or other switch this Allegro interface as ER-span destination. What is new is, number one, in interface statistics, you can see the layer 3 tunnels. The layer 3 tunnels show you all ER-span IDs that the Allegro receives. So here you get a list. Okay, I receive 20 or more tunnels from this source IP. This helps a lot to debug. Are my ER-span really forwarded to the Allegro? That's number one. Number two, we added the ER-span support for the virtual link groups. So the virtual link group is a feature that you can group traffic and then have here a view per group. So you can split your incoming traffic in multiple links. We added the ER-span support to that. So what I have here a virtual link group which matches ER-span ID 10. And now all traffic coming from ER-span ID 10 is separately analyzed. So you can now, if you have 20 switches where you mirror 20 ports of maybe VoIP phones, for example, you can forward all 20 directly to the Allegro, and you can then see each of these forwards separately as its own virtual link groups. And I think we support more than 100 virtual link groups, so there's room for a lot. I think 100 is the maximum number. Okay, last but not least, if you do a capture, you can do the same now with a capture. So if you say, okay, don't save this on a disk, don't forward that directly, the packet on the interface, you can also forward captures on ER-span. So for example, you could use a local Allegro to filter out very specific traffic. So you only like to see from that IP address only the DNS traffic, for example. Then you can forward that traffic to a target, for example, another Allegro with a specific session ID. And if you do it like this, so from now unlimited, then it's ongoing running and forwarding packets in real time via ER-span to a second Allegro. So that can be used, for example, to filter on remote site for very specific traffic, forward that traffic to a bigger centralized Allegro in real time. Okay, that was ER-span. So coming back to my list, next item is queue overcommit, which sounds very complicated and cryptic, but it is quite simple. We have seen in some installations of very, very large Allegros with 10 gig and above that we on and off have seen a few packets not processed because of overload. We debugged a lot. How could that happen? Because we had a lot of resources free, everything. The case is quite simple. The Allegro, of course, tries to do as much power saving as possible. So we put all the analyzers, which process the traffic, into a deep sleep mode, which saves a lot of computing power. And they're only activated if there are packets. What can happen is that, for example, one analyzer is sleeping, and then there is a sudden burst. For example, one connection is sending line rate on 40 gig or on and off even on 10 gig, a very high packet rate. Then the wake up process is too slow to handle that. So we decided, okay, we add a special mode here, which is the analyzer queue overcommit mode, which means if there are very short, very high bursts, try to buffer as much as possible. We recommend that mode only for sync mode because, if the device is out of packet buffers, even forwarding a bridge mode might have problems. So, and it helps if there are very few short overloads. So random overloads you see maybe a few times a day or a few times in an hour. This mode helps a lot. We did that on many installations and it helped removing the very few drop packets. We are working again on that mode with 100 gig now to do that also there, to have there more and more really receiving packet rates with zero drop for, I think we are right now at 15 to 20 million packets per second with zero drop. We're trying to push that border to 30, 40 million packets per second with the high-end appliances. Okay, next feature on my list is the graph selector. Well, that's a nice and easy feature. Very simple request. You see the IP statistics. You see here a lot of IP addresses. You see a lot of values. So for example, you have 0 windows and you thought, okay, who has sent or received most 0 window packets? Now the problem is you have the value here, but not the graph. With the 3.0, you can change the default graph, which is shown here on that overview. And for example, we can see here the 0 window graph. Or you can show here the MTU graph or the new client connection graph. So you can switch the graph, and that makes it a lot easier to show what a graph you would like to compare on that page. And that makes the debugging from our perspective a lot easier and a lot simpler to use. And you don't have to go to that IP, then see the special graph and then go back. Okay, this works for IP and MAC statistics and a lot of other modules. We already added that, like zip and I think IP groups. It's the same. It's all also available here for all the group statistics. So which group had most of the bursts, for example? Okay. Next item on my list is the improved storage view. So if you do captures on the internal disk, there's a storage. And well, the view before was very simple. What you can do now with release 3.0 is you can, first of all, you can upload files. You can create directories and of course navigate to them. But also what happened on some customer sites, people decided, okay, I would like to record that PCAP, split by 1 megabyte, and then write it to disk. And they forgot that the capture is 10 gigabyte, which resulted in 10,000 files. So then you just type in the beginning of that capture, what I can do here for that name, and then I filter for all these captures, and then I can say, okay, delete all filtered captures. And that makes it very easy to delete tons of PCAP with just one click. Okay, there are 2 small features left on my list. One is the firmware update. We added a mode that the Allegro can automatically poll our update server if there's a new release. And if there is, you get a small information that there's a new release and then can install it, and that makes it easier for you to use. We decided to do that here. By default, it is off because the Allegro as a measurement device should generate as less traffic as possible. So right now, if you connect the Allegro, it will ask for a DHCP address. And if it got one on the LAN port, it will ask the NTP server for a date to be always in sync with NTP. That's the only 2 things we do. If you activate that, then of course it will poll automatically our update server. Okay, last item on my list is SNMP v3. We got, well, up to now the Allegro had only support for version 1 protocol, but we got a lot of requests that we need to support version 3 because of compliance regulations that v3 allows a lot better integration in terms of security because it's more protected, it's encrypted. And so we added version 3 support, which was now easy because we got new libraries with the updated base system and could eventually add now SNMP version 3. There are a lot more changes, improvements, bug fixes. We documented them all in the release notes, but that is way too long to explain everything today here in that webcast. And so I decided to select all these small things. Again, as a recommendation, we can go much more into detail after now the recording, and you can contact us on support@allegro-packets.com for feature requests, but also for bugs, of course. And we will be happy to help.